Hello again. Welcome to 8.3. Last time in 8.2, we alluded to these z-scores a lot, but it wasn't quite time to dig in and figure out exactly what they are. But we did preview them quite a bit. And so we'll recap all of that again here, and we'll, of course, go a little bit further and figure out exactly what z-scores are. So we use the z-score to find probability of events occurring and to compare different distributions. To do this, we use the normal probabilities table. I should probably pull that up for a second. Let's see, because yeah. I'm gonna pause this for a second. I'm gonna pull the probabilities table real quick. All right, so this is the z-score table. So what we kind of mentioned last time is any normal distribution, right? Any normal distribution with any kind of mean or whatever, or any kind of standard deviation, right? Can be converted into a standard normal distribution, which basically just converts whatever your mean is, whatever your standard deviation amount is, to 0 and 1, putting the mean right on top of 0 and a standard deviation measuring exactly 1. So, because every normal distribution has the mean in the center and a standard deviation of 1 somewhere, right? So you take any distribution at all and you can convert it to the standard normal distribution, which uses this scale. And because it's converted to a universal scale, somebody's already done all the calculus to find the area under a normal distribution on that scale. So for example, at negative 3.4, let's say negative 3.49, right? Negative 3.49. So if your z-score is negative 3.49, what that means is that you're talking about the negative 3.49 standard deviations from the mean. So whatever the distribution is, this would be the distance from the mean standard deviation wise. So negative 3.49 standard deviations below the mean. So that would probably be, again, somewhere on the scale, somewhere like all the way over here, right? And so somebody's calculated the area under the curve to the left, because this is very important that the area is always counted to the left. And that area, as you can see, it's a very small sliver, is only 0.002, or in percentage terms, that would be 0.000, yeah, no, 0.002, no, I'm sorry, 0.02%. As a percentage, that number would be 0.02%. So 0.02% of the area. So, you know, not very, very small, not even a 1%, right? Way less than 1% of the area is that tiny little sliver right there. So to give you a little bit more context of how a z-score works is, let's say you found a z-score. Let's go to like a z-score of 1.23, right? So 1.23. So just so you know, you have the tens place down here. So, 1.1, 1.2, 1.3, but across the side, you have it to the hundreds place. So like the z-score of 1.20 is this number. 1.21 would be this number. 1.22 would be this number. Because you could see you've got the 1.2 and then the hundreds place is here, right? So like 1.23, like I was saying, well, you got 1.2 and then the 3, 1.23 is that number right there, right? 1.23. So that is 0.8907. Come on, stay with me here. 0.8907. So what that means, if we go back to our distribution here, kind of when I sketched out earlier, a standard deviation at 1.23, which 1.23 would probably be something like right about here, right? Because it's, about 1, obviously between 1 and 2, and it's about a quarter of the way through, right? 1.23 is probably right about here. What that tells us, that 0.89 number that we saw, 0.8907, is that the area under the curve to the left is that big. It's 0.8907, right? So this whole area that I'm shading in here, right, is 0.8907. Or you can translate it to 89.07% of the distribution is 1.23 standard deviations or less, right? And don't forget that the whole area would equal 1. So if I were to shade everything in, right, let's say we go all the way to a z-score, like all the way at, I don't know, let's say 3.5 standard deviations, right? 3.5 standard deviations, as you can see, this is 3.49, right? Because you got the 900th place, 3.49 has an area of 0.9998, which basically means 99.98% of the distribution is less than that. So if you went from 3.49 down to the left side, you would cover 99.98% of the curve. So almost the whole thing, basically. So that's kind of the gist of how this works. And you can see, again, all the area amounts filled in for any z-score you want, from basically negative 3.5 to positive 3.5. So let's jump into this. The average speed of vehicle traveling on a stretch of highway is 67 miles per hour with a standard deviation of 3.5 miles per hour. The vehicle is selected at random. The speed limit is 70 miles per hour. Assume the speeds are normally distributed. Find the z-score for a person driving the speed limit. So this is our formula that will help us convert any distribution to a z-score, right? It's a pretty simple formula. It's very nice, very useful. So as you can see, this distribution here, let's draw it out. It said that the average speed was 67 miles an hour. Now the standard deviation was 3.5. So one standard deviation would be, this would be at 70.5, right? This would be 74. This would be at 77.5. And if we went backwards, let's see here, this would be 63.5. This would be 60. And then this would be 56.5. So remember, this was the mean, and this was 1 standard deviation. This was 2 standard deviations, 3 standard deviations, and then of course, -1 standard deviations, -2 standard deviations, -3 standard deviations. Now, we're looking at z-score of a person driving the speed limit. So this person driving the speed limit is going 70. So here's how we'll use our formula. Z is equal to the x value, which in this case is 70. That's the person's speed that we're measuring, minus the mean, which is 67, divided by the standard deviation, which was 3.5. So simply type that in the calculator. Where's my calculator at? Let me grab it real quick. So 70 minus 67, of course, that's 3 over 3.5. And 3 divided by 3.5 is 0.86. 0.86. Now it's really 0.85714, blah, 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 blah. But when it comes to z-scores, always round to 2 decimal places. And that's because if you remember the z-score table, the z-scores are all in 2 decimal places, right? 1.23, like I said before, right? That's z-score. We don't have a z-score that goes to the thousandths place, the 3rd decimal place. So we can only go to 2 decimal places. So always put z-scores in 2 decimal places. All right, so 0.86. What that means, 70 miles an hour is right here, right? That's roughly where 70 miles an hour is. Let's put it in a different color for now. Right? 70 miles an hour is about here. But that is, as you can see, 0.86 standard deviations away. So if you kind of look at it on this scale, you know, it's obviously not 1 standard deviation, it's a little bit less. It's, as we can see, 0.86 standard deviations. That's the z-score. So that's how many standard deviations it is from the mean. So find the z-score for a person driving 62 miles an hour. Okay, we can do that. So similarly, let's use a different color to point this out. So z equals, so if they're going 62, that's going to be our x. 62 minus the mean, which is 67, divided by standard deviation, which is 3.5. So the mean and standard deviation are not going to change, right? They're still 67 and 3.5. But the x value that we're finding the z-score of obviously does change. So 62. This is going to be negative 5 over 3.5, which comes out to negative 1.43. Negative 1.43. So 62 miles an hour is obviously somewhere about here. Right, that's where 62 is. And again, as you can see, that its z-score is negative 1.43 standard deviations from the mean. Right, and that makes sense because as you can see, it's more than one standard deviation, less than two standard deviations, so it's between them. So it's negative 1.4 standard deviation, 1.43 standard deviations from the mean. And one more, we're gonna find the z-score. Let's do this one in like purple for 80 miles an hour. So z equals 80 minus 67 divided by 3.5. So 80 minus 67, that's 13 over 3.5, which is, oops, 3.71. So that z-score would be way out here, right? 80 would be way over here. Obviously beyond 3 standard deviations, as you can see, with a z-score of 3.71. All right. Continuing on here. A farmer records the mean weights of the pumpkins he has harvested. The weights are normally distributed with a mean of 22 pounds and a standard deviation of 3 pounds. So let's draw this one out. All right, so mean of 22 and a standard deviation of 3. So this would be 25, 28, and 31. And if we go backwards, it's be 19, 16, and 13. All right. Now here's what's interesting. We're gonna go backwards. We have the z-score here, but we need to find the x value. The x value here would be the actual pumpkin. So how much does a pumpkin weigh? That would be negative 1.24 z-score. All right, so let me put my scale back up here. Remember the mean's in the middle. You have 1 standard deviation, 2 standard deviation, 3 standard deviation, negative 1 standard deviation, negative 2 standard deviation, negative 3 standard deviation. Now, if this z-score is negative 1.24, right, that's going to put it somewhere between negative 1, negative 2 standard deviation, somewhere about here, right? So it's probably going to be close to like 18, for example, right? Because that z-score, as you can see, that z-score would be about somewhere around negative 1.24. So for our prediction from our number line here is it's probably close to something like 18, but here's how we can figure it out for sure. We'll take the z-score. Remember the formula? Z equals x minus the mean divided by the standard deviation. Well, we have 3 of these numbers. We know the z-score is negative 1.24. We don't know the x, but we know the mean is 22. We know the standard deviation is 3. So now it's just an algebra problem that we solve. So simple algebra problem, we can do this. So we'll multiply both sides by 3 to cancel this out. That gives us, let's see, 3 times negative 1.24 is negative 3.72. So negative 3.72 equals x minus 22. And then, of course, we just need to add 22 to both sides to cancel it out. And so when you add 22 to both sides, we end up with x equals, let's see, what's negative 3.72 plus 22, 18.28. 18.28 is our answer. That's how much the pumpkin weighs that has the z-score of negative 1.24. And that makes sense because, like I said, we predicted it was probably around 18. So that's perfect. All right, now we're going to do the same thing with this one. So first, I'm going to point out that 3.25, the z-score, 3.25 is beyond 3 standard deviations. It's probably something around here, right? That's probably your z-score at 3.25 because, again, it means 3.25 standard deviations. So it's a little bit past 3 standard deviations. So it's probably around 32 would be my guess. So when we get our answer, we should be expecting it to probably be close to 32. So let's work it out. We have, oops, we have 3.25 equals x minus 22 divided by 3. All right, and obviously, again, same algebra rules apply. So we're going to multiply by 3 on both sides first. Cancel that out. Let's see. 3 times 3.25 equals 9.75. X minus 22. And then, of course, add 22. And we end up, let's see, add 22, we get 31.75 equal to x. So that is our weight of our pumpkins. That is what we have here. It's 31.75, which makes sense because, like I said, I remember we predicted it would probably be close to 32. And it is, right? A little bit past 31. That makes perfect sense. So nice going. All right. Let's just do a few more for practice just to find the z-score. So to save us time, I'm not going to draw out the distribution for explaining purposes like I had with these ones. I'll just do the math for it, right? We'll just practice the math. All right. So Tiffany scored a 53. Find the z-score for Tiffany's exam grade. Okay, z is equal to 53 minus the mean. The mean was 67. And then our standard deviation was 5.5. So just a simple math equation, right? 53 minus 67 is negative 14. And then divided by 5.5. We get negative 2.55 as the z-score. All right, so again, let's try it on this one. The grades on history midterm at Santa Rita are roughly symmetric with a mean of 76 and standard deviation of 3.0. Ben scored a 71. What's his z-score? So we have z equals 71 minus the mean, which was 76, divided by standard deviation, which was 3. So this would be negative 5 over 3. And negative 5 divided by 3, of course, equals negative 1.67. That's their z-score. And then a couple more. We have Emily scored a 92. So z-score, we have 92 minus the mean, which was 82, divided by standard deviation, which was 4. So this is going to be 10 over 4. And 10 divided by 4 equals 2.5. That's your z-score there. And then one more time, Stephanie scored an 86. What color haven't I used yet? Green. All right. So z equals, Stephanie's score is 86 minus the mean. Mean was 72 divided by standard deviation, which is 4.5. So just using the formula over and over and over again. 86 minus 72 is 14. 14 divided by 4.5 is 3.11. All right, so calculating the z-score is pretty simple, right? Just using the formula. But just remember that those translate to standard deviations basically. Like how many standard deviations from the mean it is. So you can see this is 2.55 standard deviations below the mean. This is 1.67 standard deviations below the mean, et cetera, et cetera. So hopefully drawing these out really helped explain it and understand how a z-score works. If not, just ask me and I'll be happy to continue helping you. But for now, we'll pack it up and I'll see you